25 plus I squared sine 200 sine 25, like that. That's just from foiling. Is that okay?
Yeah.
So the I squared's -1. So you group those together. I'm missing a 3. There should be a 3 there. I should have probably just left the 3 off. I mean, it's kind of an irritant anyway. So let me leave it off here. Cosine 200 cosine 25 minus sine 200 sine 25. So the idea is that you're supposed to be like, oh, I recognize that. That's a double angle formula or sum and difference formula or half angle formula or whatever it could be. Like, everything is in play here. This one's cosine, cosine, sine, sine. So it's a cosine. It's a cosine of adding them of 200 plus 25, like that. Now, you may have learned a shortcut here. This is the long way to do it. And then you've got 3i cosine 200 sine 25 plus sine 200 cosine 25. And that's yet another one. That's a sine, cosine, sine, sine, cosine. Depending on how you look at it. This becomes sine of 225, 200 plus 25. And you have the 3i on the outside. So this is 3 cosine 225 plus 3i sine 225. And then you're supposed to be able to go to your unit circle and know, what each of these are by now. Is that something you're
Um,
comfortable with?
it's cosine 225 is negative root 2 over 2, and then sine 225 is negative root 2 over 2.
That's right. So you can simplify your final answer. -3 root 2 over 2 plus -3i root 2 over 2. And that is it.
Okay, that makes sense.
Now there's a shortcut, like, I don't know, did your teacher show you the shortcut? I mean, you could kind of see what happened. We ended up getting,
Just adding those two.
yeah. And so I don't really know if you're expected to show it or just know it. Um, I couldn't tell you the last time I worked on this with a student. So I mean, while I know that exists, it's not really front and center in my knowledge bank. But this one is basically identical. Do you want us to do this?
No, I think I can figure it out based on how we did the last one.
Okay.
I mostly wanted to focus on the middle section and then, well, middle to the bottom.
Okay. We should do one more of these divide problems, or one of the divide problems, unless you really don't want to.
No, we can.
Okay. Um, it's let's just deal with the 18 over 6. That's 3. That's kind of off to the side. And then it's a, it ends up turning back into what we just did. You end up multiplying the top and the bottom by the conjugate. So cosine 55 minus I sine 55. Cosine 55 minus I sine 55. So the bottom here is kind of the big one. It becomes cosine squared 55 minus I squared sine 55, which ends up being plus cosine squared 55 plus sine squared 55. That becomes just 1 by the Pythagorean identity. Is that
Oh
clear?
yeah.
And that always
So the
happens.
I doesn't affect it. Would it not be one I
Becomes
or one
I
minus I?
squared is -1, so you can see how that double negative becomes a plus.
Oh yeah.
That's a sine squared. And then the top is just like we did in the previous problem. So we don't necessarily need to do that. I do think there's a shortcut to these. Look up, see if this reference sheet even has it. See, this isn't really trig anymore. I'm just gonna just give me like I want to look at a book real quick. This could go a lot faster. Let me be right back with you.
Okay.
Okay, yeah, this is called the product theorem. Glad I looked. Um, did you guys cover that though? I mean, in class, the product theorem.
Yeah.
Okay, so that's the shortcut here. Um, basically, and we need this for that. You basically take 3 and the 1. Those are called R1 and R2. You multiply those together, and then you uh, add the angles, which doesn't seem to make sense. Seems like you should subtract these. Anyway, that there is a shortcut there. That's why I don't like looking at these books because they're not really helpful. So there's also the quotient theorem where you subtract the angles. You should probably look at those. They really shortcut this quite a bit. Do you know what I'm talking about?
Yeah.
Okay. So like, because like the problem we just did, you really don't need to do what we just did. You end up subtracting as it being cosine 45 and then sine 45 like that. And then you take the ratio of them.
Root 2 over 2 plus 5 root 2 over 2.
Yeah. Okay. Now I know so that kind of all leads into DeMoivre's theorem. So let me write out DeMoivre's theorem for me because I haven't done this in forever. Um, so it's r cosine theta plus I sine theta to the power of n, all to the power of n. Sorry, it's all to the power of n. Becomes r to the n cosine n theta plus I sine n theta. That's something you remember seeing in class.
Yeah.
Right. That's kind of that's where we're going here with the first one, number 5.
Okay.
Okay, so basically it's mapping the equation that so it becomes 2 to the 9th cosine 9 times 100 plus I sine 9 times 100. Okay, so this is the 2 to the 9th is 256. No, 2 to the 10th is 1024. So it's 512.
512
Yeah, cosine
cosine
900
900.
plus I sine 900. So this is where you got to go back if you're doing it by hand. Yeah, that's 360.
180.
That's 720. Yeah, so it's really 180. So what is cosine of 180? It's -1. What is sine of 180? 0. So it's -512. Is your answer.
Okay. Yeah.
W is exactly like V. It's just written in a different form. So let me sorry, get this up here. So you have to figure out like how to go to into like sine and cosine. Maybe that doesn't make sense. How do I want to do this? So the x is kind of like square root of 3 over 2, and the y, because you're so let me do it this way. Um, yeah, so this is 2. Let me just give you the answer. Maybe that'll be easier. This is 2 cosine 30 plus I sine 30.
How did you get to that?
Yeah, so you in a previous section you learned how to convert between polar and rectangular. Do these equations look familiar?
Yeah.
So like square root of 3 squared plus 1 squared equals r squared. So you get 3 plus 1, 4 equals r squared. So r equals 2 plus or minus 2. And then
Okay.
theta is the tan inverse of y over x. That was another one.
Mm.
So that's the tan inverse of 1 over the square root of 3. That's not on the unit circle, but 1/2 and root 3 over 2 is, which is 30 degrees. Yes, no, maybe. Is that
No, that
okay?
makes sense. Yeah. Thank you.
Right. Yeah, this is tough. Like this is hardcore stuff. I mean, I'm helping a couple of trick students. They're not doing this. You get the hard stuff here. So now that you have this is all to the power of 10, which means it's just like the previous problem. Now it's 2 power of 10 cosine 10 times 300, 10 times 30 plus I sine 10 times 30, 1024 cosine 300 plus I sine 300.
Cosine would be 1/2, and then sine would be negative √3/2.
Right. And that's, it's up to you or the instructor if you have to multiply these in. Um, why not? 512 minus 512 square root of 3 times I.
Okay.
Uh, so the next one's where it really gets crazy. Okay. Um, Kind of like the last problem, you gotta figure out what the angle is the other thing that helps you is that it's sort of just like before where, if this is X and this is Y, you're going left and down, you kind of have that sense of where you're going. It's in the third quadrant there. Do you want to find the angle for us, please, and the value of R like we did in the last problem?
The square root of 4 root 3 plus 4. I.
So R is X squared. R squared is X squared plus Y squared. So it's 2 squared 3 squared plus -2 squared.
12 plus 4, 16. So R is 4.
R is 4. Yeah, and so the harder one is the angle. Beta is the tan inverse Y over X. Do you want to calculate that angle for us, please?
-30, so 30 degrees.
No. Are you using a calculator?
Yeah.
Okay. That's, I mean, are you allowed to use one on the test?
Yeah.
Okay. So one of the problems with that is um we're not even, I mean, not even in the right quadrant. -30 is over here, which is okay, but then the one that we would want, you'd have to add 180 to. The answer, it's in the third quadrant. I'm sorry. You're in the fourth quadrant, but the issue here is that the calculator gives you -30. You want the other angle, the 330. So you gotta be really careful with just using the calculator for this. Okay. Now that you have that, this is where it gets really awful. So here is what you have. You have 4 cosine 330 plus I sine 330. Okay. But you're trying to find the cube root. Okay. All right. So that is um so you're trying to find this to the power of 1/3, basically.
How do you
This
know
one
it's
is
to the
more
power of 1/3?
cube root,
Oh, okay.
cube root, yeah. Okay, so here is how we proceed. It is the cube root of 4 times what's called the cosine of alpha plus I sine alpha, and alpha equals theta, which you have, plus 360 times k over n. Okay. N in your problem is the cube root, is the root number, the 3. K starts at 0 and goes up to n minus 1. So it's a little bit involved here. So you start by letting k equal 0. Does this look at all familiar to what you did in class?
Yeah.
Okay. So when k is 0, alpha is equal to 330 plus 360 times 0 divided by 3. which ends up equaling 110. Is that okay?
Okay, yeah.
So it becomes the cube root of 4 cosine 110 plus I sine 110. And that's whatever it is. You can go calculate that if you want. Next thing
Would
you
we
do is for
need
K.
to calculate that?
Depends on your instructor.
Hmm?
Depends on your instructor. I mean, this does not work. Like, it's not a nice answer.
Yeah.
They'll probably choose one of the tests that is nicer. Then you let K equal to 1. So alpha is equal to 330 plus 360 times 1 over 3. That's 690 divided by 3 is 130. That doesn't seem right. 230. Okay. So that becomes the cube root of 4 cosine 230 plus I sine 230, like that.
And then we could leave it as cis 110.
You can change, yeah, you can use that notation as well. Then when K is equal to 2, alpha is equal to 330 plus 360 times 2 over 3, which ends up being 350. Here's something very important. All of these numbers for alpha, they have to be less than 360.
Okay.
All right, so then you get your last one there. I don't really know what the instructor means by graph these. I mean, I guess you're graphing them on the complex domain. I don't know. It's kind of weird. You could graph them on in the polar, but I don't know. Like the if you had a circle here, we had, what did we say? 130, 110, 230, 350. I mean, you've got 130. So cube root of 4 cis 130. Is that kind of what they were doing?
Yeah.
Okay, 250. And then 350. I don't really think it means much, but that's what they're asking for. Any questions on that?
Makes sense.
Do you want us to do another one like that?
No, I think we can move on to the next question.
Okay. All right. This one is quadratic formula. Not really sure why the teacher is having you do this. Maybe I'm missing something. Did you do this in class another way?
No, that makes okay, yeah, so just be quadratic.
Yeah.
And then I can figure that out then.
All right. There are there are some issues, inside here. You're gonna have some eyes and stuff on that. All right, Z. All right, so the fundamental theorem of algebra says that there are 4 solutions to this problem. So we know that x, which is maybe a little weird, x to the 4th has to equal minus 81i, which is really 0 minus 81i. You might say, why would you do that? So this is now a cis problem again, where your r squared is equal to x squared plus y squared. Um, you can maybe figure out pretty quickly that the angle there is 180, and the r ends up equaling 81. So this is really x to the fourth equals 81 cosine. No. Why am I so confused? Sine? I lost my place. Um, no, I gave you the wrong angle. That's why this isn't working. It's there, 270. Cosine 270 plus I sine 270. Uh, because you're going down, down means you're on the y-axis there. That's okay so far.
Yeah.
All right, now it's, you didn't, we did x, z is like x now. You need to take the fourth root of this, which is like what we did before. So the you're going to take the fourth root. Well, you're going to let k equal 0. That's the first thing. So alpha is equal to 270 plus 360 times 0 over 4. 4 because of that number there. A always starts at 0. So it's
67.5.
yeah. Sometimes it doesn't mean much. So it becomes the fourth root of 81, which is 9. So we'll just start writing that. It's 9 cosine 67.5
Is
plus
9 not the
I.
square root?
Yeah, it should be 3. Thank you. All right, and then k equals 1. Alpha is equal to 270 plus 360 times 1 over 4. Ends up being 157.5.
Yeah.
So it's 3 cosine 157.5 plus I sine 157.5. The angle still under 360, so you keep going. Alpha is 270 plus 360 times 2 over 4, which is now 247.5. 247.5 plus I sine 247.5.
Okay.
And then one more, k equals 3. Alpha equals 270 plus 360 times 3 over 4, 257.5. Like that.
Okay.
Do you want a problem like that to try on your own that's maybe easier, less sophisticated?
I was wondering if we could move on to the last 3 I wrote.
So those are more like W, meaning like we've actually done 3 like it.
Can
So
we do the second one?
sure. So let's go back and look at what we did in W. It's basically the same thing. All right, so in W, we first figured out the angle. Very, very important. You got to figure out the angle. That's the x squared plus y squared equals r squared. Then we rewrite it in this form. So I'm going to ask you to find the angle for us, please. And the r. R is x squared plus y squared. Tangent of theta equals y over x. Quick. That is a negative. You're again in the fourth quadrant, so you're welcome to use your calculator if you want for that.
Is it 315 degrees?
Yeah, 315 degrees. And then what's r?
Um, is it 1?
R is 1.
Mhm.
So the way we write this is 1 times cosine 315 plus I sine 315, all to the power of 8.
And
Okay, so this
then,
becomes, yep. So it's
so for
not a root.
this in rectangular form, would we keep going with that or just leave it there?
No, we have to keep going. We have to write cosine 8 times 315 plus I sine 8 times 315. We have to keep going. Like, so this is 24, 2425.20, and you got to back that down to inside 360. So we have to actually get some numbers out of this. So actually, it ends up
Is a
being,
0?
yeah, ends up being 0, which is kind of nice. So cosine of 0 is 1. Sine of 0 is 0. So there it is.
Okay.
All right, where do you want to go from here?
Um, can we do another one of those problems? Like the third one or the first one?
Not sure. First one's, well, and that's in the fourth quadrant, doesn't really matter. I would do the first one. It's a little bit, maybe slightly more involved than the third one. Okay, you've got to
Actually, I had a
find,
question I was wondering we could
yeah,
do.
okay.
It's 9 and then in parentheses cosine 5 over 4 pi plus I sine 5 over 4 pi.
Okay, and what are you asked to do?
Write it in rectangular form, standard form.
Okay, and there's no power.
No.
Okay, so you got to just find cosine 5 pi over 4. But this is r and theta. It's really an r and theta problem. R is 9, theta is 5 pi over 4. So there's a better way. X is r cosine theta, y is r sine theta, which you get anyway from it, but maybe seeing it this way will help. 9 sine 5 pi over 4.
Okay. So it's just like cosine 1 divided by sine 1.
No, you gotta actually find these values. Like cosine 5 pi over 4 is minus square root of 2 over 2 times 9
How do you know that
minus,
cosine 5 pi over 4 equals?
that's on the unit circle. It's a standard angle.
Oh, okay, yeah.
The more math you take, you'll actually know the radian rather than the angles and degrees.
Yeah.
That's it. I mean, those are the X and the Y values.
So then how would I turn this into A plus BI?
Uh, Rectangular form is X.
It says rectangular standard form and then in parentheses A plus BI.
I don't see that, but the A plus BI is what we're about to have here. I mean, it's minus 9 square root of 2 over 2 plus minus 9 square root of 2 over 2i. That's the A plus BI. And then rectangular form is just the ordered pair, minus 9 square root of 2 over 2 minus 9 square root of 2 over 2.
Okay.
Anything else you want us to cover tonight?
I don't think so. One second, could I like see the
Yeah, take a look, see what else you got.
um I don't think I have any more questions unless you want to do one more of the questions from before.
I mean, unless you want to work on some, I mean, I think I've gone pretty deep into all these. You've got to get comfortable with this type of problem where you apply it in. And then I think the more challenging one, obviously, is the one where it's the roots. Those are the ones that most students struggle with, um, because there's just so much to do. You know, you have to identify the angle, and then you have to know that like K 0, 1, 2, 3, and so on, and know when to stop. So um, these are the examples I would study. You know, maybe even retry these. Um, if you've got the book, you've got the same book that I have, just 20 years newer, 25 years newer, whatever. I would try some of those problems in 8.2 if you have time,
Mm-hmm.
or 8.3, 8.4. There's a few in there. Like, actually, your teacher gave you a pretty good one, too. So, um, any other questions? Do you have things I could clarify?
I don't think so.
Okay,
So you mainly just have to remember the r squared equals x squared plus y squared, and then the
yes,
tan
yep.
inverse equals y over x.
Yeah, and then this last little thing here is another little thing. Like there's equations to go from polar to rectangular, rectangular to polar.
And the polar to rectangular, rectangular to polar is
That's what you're asking about. X squared equals x squared plus y squared equals r squared, and then tangent of theta equals y over x.
okay.
So if you're given polar, use the second one. If you're given r and theta, you can calculate x and y. If you're given x and y, you can calculate r and theta.
Okay.
Be sure to know your unit circle. That's another thing here. If you get it,
Okay, yeah. We can use the unit circle on the quiz, so
great. Then you're all set.
okay.
All right,
Thank
well,
you.
we'll stop here then, of course. Yep. Thank you.